I'm going to cover these next two learning objectives all at once. So we want to be able to classify organic molecules as water-soluble or insoluble. And then related, are they soluble or insoluble in water and an organic solvent? So we're going to be able to answer these pretty easily because of the work we did earlier. We classified functional groups as polar or nonpolar. And here is the simple connection. Polar groups are water soluble, and nonpolar groups are organic soluble, and typically a molecule is either soluble in one or the other. So we're going to go a little farther than that, because we know that organic molecules can be big and can have more than one functional group. So we might have an alcohol attached to just 3 carbons, or we might have an alcohol attached to a lot of carbons. I stopped counting. Well, one of these will be water soluble, and the other will be insoluble. I don't want you to have to memorize where the cutoff is, so we're going to use a rule of thumb. One polar group per 6 carbons is kind of our cutoff. If we have one polar group per less than 6 carbons, it's going to be soluble. One polar group for more than 6 carbons, it's going to tend to be insoluble. When you're around 5 or 6, it's hard to predict. So look for polar groups. Are there lots of them, or are there only a few? Look for nonpolar groups. Are there a lot of them compared to the polar groups, or just a few carbons compared to the polar group? And that's how you'll decide whether they're soluble in water or soluble in an organic solvent. This we labeled as insoluble in water, but it will be soluble in something like hexane. And this over here will be insoluble in something like hexane.